Hello there. Our topic for today is Principles of Motor Nerve Conduction Velocity Studies. NCV studies are an important part of an electrodiagnosis, specifically used for radiculopathies, polyneuropathies, any anterior horn cell diseases. So today we will be discussing a part of major NCV studies that include the principles for motor nerve conduction velocity studies. Before moving on to this, I would like to make certain points clear here. There are two terminologies used in nerve conduction velocity. First is orthodromic conduction and second is antidromic conduction. Always remember, orthodromic conduction is the conduction in the physiological direction. Antidromic conduction is the conduction which is opposite to that of physiological direction. So, for motor nerve, the physiological direction is from the spinal cord to the particular muscles. So, this forms the orthodromic pathway of conduction, right? So, a motor or a mixed nerve is stimulated at least 2 points along its course. As you can see here in the diagram, the G1 is the active recording electrode. As you can see here, active recording electrode. G2, this is G2, which is the reference electrode, right? And this is the stimulating electrode. This is a median nerve motor study, and the potentials are recorded from the abductor pollicis brevis. Now, the surface stimulation of a healthy nerve requires a square wave pulse of 0.1 millisecond duration with an intensity of 5 to 40 milliampere. The intensity refers to a visible or palpable contraction in the muscle supplied by a specific nerve. The parameters of measurement of motor nerve conduction velocity are onset latency, duration, amplitude of compound muscle action potential, and nerve conduction velocity. We will be discussing each of these parameters. So, the first parameter is onset latency. Onset latency, as you can see here, onset latency is the time in milliseconds. As you can see this straight line, okay, this is what is known as onset latency. It is the time in millisecond from where we once give the stimulus and we see the first deflection from the baseline. I'll repeat, onset latency is the time in milliseconds from the stimulus artifact given to the first deflection from the baseline. Onset latency is the measure of fastest conducting nerve fibers and neuromuscular transmission time, the conduction from the presynaptic to the postsynaptic neuromuscular junction. So, the second parameter here is the amplitude. The amplitude is measured from base to peak or from peak to peak. As you can see, this is the onset latency, and this, as you can see, this is the base, this is the baseline, and the amplitude is measured from baseline to the peak of the waveform. So, from base to peak. Secondly, it can be measured from peak to peak. As you can see, this is the positive peak to the negative peak. It is measured from peak to peak. The next parameter is duration. The duration is measured from the onset to the negative or positive peak, or measured as the final return of the waveform to the baseline. As you can see, this is where the waveform has begun, it has traveled and come back to the baseline. So, this is termed as the duration of compound muscle action potential. Then we have the most important portion, that is the conduction velocity. The motor nerve conduction velocity is measured by the distance between the 2 points of stimulation. As you can see, these are the 2 points of stimulation, and the conduction velocity is measured as a distance between 2 points of stimulation, that is then divided by the latency difference. Latency difference is this proximal latency minus the distal latency. So the distance, this is the distance, as you can see, the distance between the 2 points of stimulation in millimeter divided by proximal latency minus the distal latency, and it is expressed as meter per second. So the proximal latency minus the distal latency is the conduction time, as we have discussed earlier that the latency is measured in milliseconds from the stimulus artifact to the first deflection from the baseline. Conduction velocity is the distance between proximal and the distal latencies. So this was a brief idea about the principles of motor nerve conduction velocity studies. Thank you.